So the title of the talk is what controls the inner core side of the tropical cyclone. I think this title is too big because I couldn't finish the whole stories about the water control. That's a lot of things to control the inner core side of tropical cyclones. But I will highlight some important issues and also the current understanding of the problem. So this is the outline of my talk. The first I will give a very brief introduction, and the second is how to define the inner core side in the literature, and then what's our current understanding about the tropical cyclone size and size change. And then I will give you briefly say why I do talk about this topic and the objectives, and also including my working hypothesis. And because I used the idealized simulation, so I have to give you a briefly about the model I used in the study, and then I will show you some results from scientific experiments to verify my hypothesis, and finally I will put the conclusion and the implications of the results. So this shows you the different sides of the observed tropical cyclones. I show you 3 examples from the paper of Greg Holland and the Merrill in 1984. So what you see here is the tropical cyclone. That's the typhoon, super typhoon tip in the West North Pacific. It's a long time ago. So you can see this is the radius. This is the wind. So what you see here is the wind they tend to a very large radius for tip. So that's a very large, huge size of the typhoon. The other 2 tropical storms in Australian region is Tracy and Kerry. So what you see, the Tracy is a very small cyclone. So the horizontal line here showing you the so-called damaging wind, the radius of damaging wind, or the damaging wind. The radius of damaging wind differs differently, quite large for the 3 storms. So one is about 500 degrees, and one is about just 2 to 30 kilometers in radius. So in addition to the different size of the storms, for individual storms, its size may change in its life cycle. For this example is showing you example of the typhoon, super typhoon Chaba. So you can see at the beginning the storm is a very small size and very compact eye wall and small eye, and then the storm expands a lot. That's the observed rainfall. You can see the size eventually you can about double, more than double the size. So one important feature you can see the development of the outer spiral rain bands at the beginning, and then the formation of the second eye wall feature, and then the replacement of the inner eye wall by the outer eye wall. So the storm size increased with time for this case. So because the topic here is about the inner core size, so I have to describe a little bit about the definition of the inner core size in literature. So mainly the tropical cyclone size we measure in the past research or operations. So you can see some differences, some different definitions, like the radius of the eye, the radius of maximum wind, and also sometimes we use the gale force wind and the damaging force wind, and also the hurricane force wind. And in the early days, we mostly use the outermost closed reservoir surface pressure fields. So in a study in 1988, the Weatherford and Gray, they defined the inner core as an area within 1 degree latitude radius, and the outer core is 1 degree to 2.5 degree latitude. So that's for different storms, you can see the definition of inner core seems it's a fixed radius. That's probably is not good to use for the very large storms. So what I proposed in 2008 paper, so I argued that to balance the dynamics, if the region, inner core, in the inner region of the storm, if the balance the dynamics can describe the 4 features or most of the dynamics, and then that's roughly the 3 times of the radius of maximum wind. I can define this is the inner core region. So in the inner core region, normally there are very the filamentation time is pretty short. So that's what we call the rapid filamentation zone. So in this zone, it's mainly the dynamics is controlled by the balance dynamics. We called the inner core. So in this study, because this is very hard to define sometimes, and in this study we just simply defined the inner core size as the radius of the damaging force wing. So that's the, in observation you can see the radius of the damaging wing varies from about 30 kilometers to more than 150 kilometers. So what's our current understanding of about the inner core size? So if you talk to many people like Greg Holland and Ross Ashbury here, and they may tell you the size of the initial disturbance determines the size of the tropical cyclones to some degree or to a large degree. But this actually has not been demonstrated so far from theoretical work or from statistically observational analysis. So the second is the regional work by the Macaulay and al. They identified two major processes that may cause the increase in inner core size. So the first one is the development or the replacement of the concentric war cycle. The second is the moderate vertical shear. So, but they haven't shown what's the really physical mechanisms, but that's just from observation. They give the statistical analysis and from observation data. So in my 2009 paper, I found that diabatic heating in the outer ram bands is the key to the size increase of tropical cyclones. And this also is relevant to the work by Here and Lackman, because what determines the heating in the ram band, of course, the relative humidity in the near core environment. So from the previous study, we can see the concentric war and vertical shear is important, and also the heating in the outer square in the ram band, and also relative humidity in the environment is important. But there's nothing to do with the initial size of the cyclones. We haven't done yet. So the objective of this study, mainly the three listed here. So the first is we try to understand what controls the inner core size of a tropical cyclone and also its change. The second is, are there any differences in the vertical structure between tropical cyclones with large and small inner core sizes, and how the large size of the storm can maintain, or what is the mechanism? And finally is what factors that can lead to tropical cyclone inner core size change. So before I talk about the results, first I give you some hypotheses and the initial source. What's